This is basically the layout of the toolbox underside, and these are where the casters bolt onto. The Craftsman toolbox's measurements are approximately here. I think these are pretty close, so we'll see how the fit up is. The box is approximately 26 7/8 wide and 18 inches deep. Now the reason why it's 7/8 is because at the bottom edge they folded up the bottom so that it would increase its strength. It gave it a little rib. So we need to avoid the that little curled up section when we try and drop the box into the cradle. So I've got a little bit of extra room here. These are plates, and there's going to be a square tube that welds on either side of the plate, and the tube is going to attach to the undercarriage frame. And I still need to see if where I place the tubing is too far inset. I don't know. I think it'll be okay. So that still remains to be seen. So we're 1 3/4 in from the edge of the box, and we're 3 inches on center for the the gusset plates. So we'll put our tube in the middle here at about 1.5 in from here, because the tube's 1 inch wide. So that should give us plenty of room on either side for the bolt pattern. Now what I don't know for sure is the exactness of these holes. They use lag bolts to attach the casters to the toolbox. I'm hoping that the plates are good enough. They're over here on the mill. I was going to round off the corners, but I'm not sure if I care at this point to even do that. I did all four at the same time. I have a lot of clamping force here, so I didn't really have any issues with doing all four at the same time. Normally, that's not going to work out as nice. I just didn't feel like spending a lot of time doing each one individually. So who knows? Maybe I screwed them all up. Here's hoping. If I did, I did. We'll just drill out the holes bigger. Ordinarily, these would be slotted, but I don't have a end mill, I think, that's suitable for that job at the moment. It's 1018, but you'd be surprised. It's still kind of hard after it's been hit with the shear. It gives you a little bit of trouble. So if it's too far out, we'll oversize it or maybe even start over again. I'm hoping that I can weld the tubes to the chassis and then bolt the plates onto the box and then tack them so that it's already lined up, instead of going the other direction and then hoping it all fits. I think if I tack it all up, then it should fit okay. The other thing that you can't see here is that the casters are 5/8 down into the box from the lip on the edges. They do that to make the box look prettier. So this kind of causes a problem, because you can either attach the plate directly to the toolbox, or and have a 5/8 gap filler in here that then attaches to the chassis frame, or you can have the plate there align the screw holes, the bolt pattern, and then put spacers in between the tool chest and the bolt plate. But the trouble is, if you have spacers in here, then there's a chance for a torque moment to twist, depending on how the load is shifted, depending on the inertia. And there's like only one turn of this holding itself into the toolbox. So we kind of have to assess the stability and assess if there's going to be any pull out. There might be some pull out or tear out. The bolts may not have enough hold into the toolbox. They may want to twist and then shear. If that's the case, then we can go with the threaded bolt through the toolbox, through the spacer, into the bolt plate, and there won't be any shearing at that point because there won't be a way for the box to get away from the base. At that point, the whole thing tips over and crashes and destroys everything in one big mess. So I'm not sure how much tear out force is going to be required to strip the bolt from the box. This is a pretty aggressive thread to it. Hopefully there's not going to be enough lateral force to cause that to happen, or else I'm going to be out a lot of money. There's there's 16 bolts holding it together, so you'd think that that would be plenty, except there's an 80-pound welder. The box itself is like 40 pounds, and then we're going to have 2 bottles on the back, and each of those weigh 53 pounds. So if you're pulling on the cart and the inertia of the bottles and the welder wants to keep it from moving, then you're trying to overcome that static force with a lateral impulse, and that may cause these to loosen up over time. And if they get loose enough, then it won't take much to shear off because these only bite in so much. So I'm not really sure the engineering here. This is mechanical engineering. I'm not a mechanical engineer. I play one on TV. So we're not really sure exactly what's going to happen here. I could take the bottom drawer out of the tool chest and see how much thread engagement we have. It should be at least 1.5 turns, maybe 2 turns into the toolbox. I may just go ahead and get some threaded bolts and put those in anyway. Or you'd only take really 1 threaded bolt in each corner to overcome that issue. So you don't have to go crazy. It's not a bridge. But certainly 1 in each corner would be sufficient to overcome any issue like that. But we'll see how this goes. Not sure yet. Still in the question engineering phase.